Hello, in this video we are going to talk about the recommended tech stack for facial recognition tasks. But before we begin, please like the video and do not forget to subscribe to the channel. Thank you for your support in advance. Firstly, face recognition and face verification might be confusing for newbies. In face verification, we look for the answer of a question pattern like is this Mark? We have a pre-taken photo of Mark, then someone will attempt to log in into a system as Mark. Here we will compare that candidate is Mark or not. Face ID application in iPhones is a face verification task here. This has a O1 time complexity in big O notation. On the other hand, face recognition looks for the answer of a question pattern like who is this? We have the pre-taken photos of many people. When someone attempts to log in into a system, then we will look for its identity in our database. In other words, it requires to run face verification many times. That's why it has a ON time complexity in big O notation. Let's talk about the tech stack for facial recognition tasks. As I mentioned, face recognition requires to run face verification many times. So, face verification is a subset of face recognition as shown here. Let's mention the tech stack for face verification first. Face verification tasks could be handled with regular relational databases. Oracle, IBM DB2, Microsoft SQL are common tools for relational databases. Besides, mysql or sqlite are more lightweight solutions nowadays. Remember that we need the vector representation of pre-taken photo of Mark. Here the identity of Mark will be defined as index. That's why we can access its metadata very fast. No matter how large database we have, we can access we need as long as we are querying with index. Relational databases are very good for querying relational data, but we actually do not need a relational data for face verification. We just need the vector representation of pre-taken photo of Mark. That's why k-value stores overperform for face verification tasks. Here, Redis and Cassandra are popular k-value stores nowadays. No matter how large the k-value store is, we will be able to access the metadata of Mark with its index and it will still return very fast. Notice that you can use any tool of face verification for face recognition tasks as well, because face verification is a subset of face recognition. But tools for face verification will not work for face recognition when the data size becomes huge. In this case, you will need some big data solutions to run face recognition. Hadoop is a pretty way to store big data sets. You can run SQL-like queries with Hive on even petabytes of data. Besides, you can use Spark framework with Scala or Python and perform queries on Hadoop as well. Besides, MongoDB is a document database and it's very scalable for large data sets. However, big data solutions will be as strong as the hardware you have. If you have hundreds of data nodes in Hadoop, running face recognition will be performed in seconds for even billions of data. But this is a costly and expensive approach. We actually applied k-nearest neighbor or shortly KNN algorithm with big data solutions, and the complexity of KNN algorithm is ON in the big O notation. On the other hand, approximate nearest neighbor algorithm or shortly ANN has a very low time complexity. Spotify Annoy, Facebook Face, NMSLib and Elasticsearch are common approximate nearest neighbor solutions. We can run face recognition for even billions of data with those ANN libraries very fast. Spotify Annoy is the acronym of Approximate Nearest Neighbor OE, Playlist recommendation in Spotify is mainly based on this library. Consider the number of users and the number of songs in the Spotify. What's next? Facebook Face is another ANN alternative. It's the acronym of Facebook AI Similarity Search. Image tag module of Facebook is mainly based on this library. Now please consider the number of users of Facebook and the number of photos shared in Facebook. Moreover, NMSLib is the acronym of the non-metric space library. It's developed by 4 PhD students. It's very core and a very strong library for ANN as well. And finally, Elasticsearch wraps NMSLib in the background, but it comes with a highly scalable architecture. Running ANN instead of KNN comes with high speed, but you might miss some items because it just approximates. I mean that it doesn't guarantee to find the closest ones always. On the other hand, approximate nearest neighbor or shortly ANN libraries can be run on limited hardware. You don't have to invest for strong hardware in contrast to KNN. So we have mentioned the strong tech stack for facial recognition tasks in this video. If you liked the video, please like it and do not forget to subscribe to the channel. I will be appreciated for your support in advance. Thank you all for watching and see you next time.